Video presented to you by Unique to Billions e-learning. Please subscribe it and press the bell icon. Wave nature of matter. We have seen dual nature of light in previous section. That is, light behaves in certain situations as waves and in certain situations as particles. This led to a question. If radiation has dual nature, why not the particle also exhibit dual nature? In 1924, de-Broglie proposed a hypothesis that moving particles of matter should have wave-like properties. He put forward this hypothesis on the basis that nature was symmetrical and then two basic physical entities, matter and energy, must have symmetrical character. If radiation shows dual aspects, then matter also shows dual aspects. In analogy with electromagnetic radiation, de-Broglie proposed that the wavelength lambda associated with a particle of momentum p is given as lambda is equal to h by p, that is equal to h by mv, where m is the mass of the particle and v is its speed. This equation is known as de-Broglie's relation, and the wavelength lambda of the matter wave is called de-Broglie's wavelength. From this relation, we can easily understood the dual nature of matter. Wavelength lambda on the left hand side LHS shows the wave nature, and momentum p on the right hand side RHS shows the particle nature of matter. The Planck's constant h relates the two. We can express this idea by considering electromagnetic radiation. We already studied energy of a photon with a frequency nu is given by E is equal to h nu, that is equal to hc by lambda. From Einstein's energy mass relation, we know energy E is equal to mc square. Therefore, we can write mc square is equal to h nu is equal to hc by lambda. This can be rewritten as lambda is equal to hc by mc square, that is equal to h by mc. That can be written as h by p, where p is mass into velocity. This in analogy gives de-Broglie's relation for matter waves. It is clear from de-Broglie's relation that lambda is very small if m is large or v is large. That is, wavelength is smaller for heavier particles or more energetic particles. That is why macroscopic objects in our daily life do not show wave-like properties. But in subatomic domain, the wave character of particles is significant and measurable. Now, we are going to study de-Broglie wavelength for an electron. We know de-Broglie wavelength lambda is equal to h by p is equal to h by mv. We also know the kinetic energy K is equal to half mv square, that is equal to p square by 2m. Therefore, momentum P can be written as square root of 2km. Therefore, we can write de-Broglie's wavelength lambda is equal to h by square root of 2km. If a charge q is accelerated by a potential difference v, then it gains a kinetic energy k is equal to qv. Therefore, de-Broglie's wavelength can be written as lambda is equal to h by square root of 2qvm, where q is the charge, v is the potential difference, and m is the mass of that charged particle. If an electron is accelerated, then the charge is E. Then the de-Broglie's wavelength can be written as lambda is equal to h by square root of 2evm, where E is the charge of electron, v is the potential difference, and m is the mass of the electron. We know the values of h, e and m. Substituting these values, we will get lambda is equal to 1.227 divided by square root of v nanometer, where v is the magnitude of accelerating potential in volts. Another common way of writing this equation is lambda is equal to square root of 150 divided by v Armstrong. We know 1 Armstrong is equal to 10 raised to minus 10 meter. Later, de-Broglie's hypothesis was experimentally verified. The de-Broglie's hypothesis has been basic to the development of modern quantum mechanics. It has also led to the field of electron optics. The wave properties of electrons have been utilized in the design of electron microscope, which is a great improvement, with higher resolution over the optical microscope. We will study important types of problems from this chapter in another video. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.